To close out this sixth module as we come towards the end of roughly the year 1648 and the close of what we're considering Western Civilization 1, I want to start with a model here. This is a model of a universe, and in the center of it they have placed the sun, in the language of the diagram here, the soul, right, the sun. And notice that everything is going around the sun in perfect circles. That one way to explain the sun, the moon, and the stars, and the earth and the moon and everything else, is to consider the sun as the center of the universe. Now, this was actually a new theory. The prevailing theory is that earlier than this, they had placed the earth at the center, right? It was called geocentric theory. It was the idea that the earth was the center of everything. It fit the Judeo-Christian Islamic tradition of understanding how Genesis worked, that the earth had been created as the focus of the universe, the humans on the earth were the focus of the divine, and that the earth was seen as perfect, unmoving, not spinning, not tilting, and that everything went around it in perfect circles. Many different astronomers have started to look at this and calculate different things. And even though the model coming out of the religious understanding of Genesis seemed to work, observational science, astronomy, made a mockery of it. It just didn't work. The model just did not work. It was not slightly off, it was just totally off. It didn't work at all. So Nicholas Copernicus, who is one of the late medieval, early modern astronomers, building on many of the ideas of people who had come before him, are going to take a look at what was called the traditional geocentric theory, that the earth, the earth was the center of the universe. Copernicus is going to come in and propose helio, or the sun is the center of the universe. Now, it, by modern standards, is still not accurate. It is not proper, because in the system that was created before, remember, everything is in perfect circles and at the middle is unmoving. What Copernicus did was, instead of having the earth at the center, he had put the sun, okay? Now, that made calculations of how things worked in astronomy by observing the sun, the moon, the stars, and the planets. It made it work better, but it still wasn't perfect. It still did not actually work. So, as we go into the 17th century, the Italian Galileo Galilei is going to improve on the telescope. He learns that some glass makers have been able to play with their various kinds of lenses to both magnify things, and he learns to play with the telescope. He creates some of his own lenses and then does some significant observations, especially of the moon. Now, what comes out of that observation as he's doing this work in the early 17th century is that the heliocentric theory doesn't work as well either. The idea of a perfect sun, not moving, not spinning, not tilting or anything else, and being perfect just doesn't work. He observes the moon, and it looks to him as if it's just like someplace on Earth. It's made up of all the different kinds of things. There's all kinds of scars on it. That it's not perfect. Everything about it is actually imperfect. So what's going to happen is that Galileo will take this idea, and he's going to experiment and find that even though heliocentric theory is still not perfect, it's a lot closer. What he's starting to also realize with the work of people like Kepler and Brahe and Copernicus is that nothing in nature is perfect. Everything seems to be spinning, tilting, and moving. So the older ideas of a geocentric theory, where everything was in perfect circles and fixed in one point with the earth at the center, none of that makes any sense anymore. None of it. What Galileo will also do, though, like Copernicus, is be very fearful of what authorities will do to him. Because remember, the prevailing political and religious ideology is that the scriptures are being used to understand science. Galileo and other people like him are challenging that very basic principle by using human observation, experimentation, and continually checking data from multiple different astronomers about the movements of the sun, the moon, and the stars. What Copernicus had done, for example, is he published his major work right before his death, knowing that he probably would get in trouble. Galileo does not do that. Galileo puts a lot of his information out there that challenges the way that people understand Genesis. He's put under house arrest. Eventually, he's brought into essentially the court of the church, made to retract his statements, and then live under house arrest. These ideas are powerful because in an era, remember, of great religious strife and arguments about religion, one more challenge to religious authority in terms of science would be one more challenge to the whole thing. And that is something that many authorities will not like. Both Protestant and Roman Catholic Christians are very opposed to many of the things that some of the early astronomers are talking about. But the conclusion here, and this is a little bit after the time frame of our lectures, but Isaac Newton in England is working at Cambridge University in many different ways and capacities. He's working both the idea of trying to figure out how to do alchemy and magic and change lead into gold. He has lots of theories about that. But he's also doing some serious mathematical study of how the sun, the moon, and the stars operate. And it will be him that will create this idea of gravitational theory. He will offer a mathematical understanding of how the Earth, the sun, and the others move. He will offer a very simple theory that is proven by mathematical understandings and can be repeated for various objects in space. He's going to provide the simple theory of astronomy that will prevail roughly until the time period of Einstein in terms of understanding the mathematical precision with which the universe operates. And of course, later on it will be changed and improved, but he's going to be the one that provides a mathematical model to explain things like gravitation, why things speed up and slow down through space, and in many ways offer an alternative to understanding how the universe works that is not based on the interpretations of Genesis. Take a look at the early scientific revolution and some of the key factors and ideas that went into creating it, and then see if there's some sample questions to assist you in your comprehension.